Alright, hello everybody, welcome back. Today we'll be talking about Algebra 1 review. This is going to be like a boot camp, all in one. We're going to just discuss everything. Not much practice in this. Hopefully this goes well. So the first topic in Algebra 1 is lines. Now what's a line? A line is just 2 points. A line is just a straight thing defined by 2 points. And a line goes on forever. We use these arrows to denote forever, and we draw 2 points to denote those 2 points. A line segment is just 2 points, and then a ray is from a point to an arrow. Okay, cool. So now, we're going to be talking about the forms of lines. That would be so we graph it like this: y equals mx plus b, m equals a slope, which is equal to the change in y over the change in x. B equals a y intercept, and that's equal to f of 0. And this is y. Y is equal to f of x. F denotes a function. It's a function with input x and it outputs y. And so f of 0 means that you input 0, so you're gonna get b, right? Because x is 0, so 0 times m is 0, so you're left with b. These two are equal. Cool. Yeah, now that's one form. There's much more. But first let's talk about mx plus b. If we had our little graph here, that would get us, that's not really a good graph. So we had a graph. Right, that's good enough. So now b would be here, right? It'll be on this axis, alright? It won't be in any other place. On that line, you define b. Let's say it's right there. Alright, that's b. Now m, let's say we take any arbitrary point that's on the graph. So let's say this point. This is the change in y, right? If we make this little line, right, this is a right angle. This would be the change in y. This would be the change in x. The change in y and change of x are not defined as one thing. They could be many things, but the ratio is defined as a slope. So let's say we could do it up here. Here, the change in y and change of x are different, but the ratio is the same. Sorry, yeah, there. So you can choose any two arbitrary points, and then the ratio of the change in y over the change of x is the same. Note that when you go up, that's a positive change in y. When you go down, it's negative, and same for right and left, respectively. So yeah, now that's how the graph of the line works. It goes both ways. You find 2 points and you keep graphing it. And then m is a slope, change of y over change of x, and that stays constant over the whole graph of a line. Next up, we're going to be talking about point slope form. That would be in the form, sorry, y minus y1 equals m times x minus x1. That means that m is still the slope, which is equal to the change in y over the change in x. And then we also have that x1 comma y1 is any point on the graph. In other words, what we have is that f of x1 equals y1. Oops. And we're still coming back here where y equals f of x and f is a function. This is not gonna, okay, cool, whatever, let's do that. Now, let's say we'd still get the same graph of a line, right? You could also add y1 to both sides, but there's no point in that, so we're not gonna do that. Yeah, and why is that the case? Well, that's just saying that, if we had this, right? If we had a little line here, right? Alright, so now what we have is that if we have some point random x1, y1, and then we have any other point, we'll say it's this, the y-intercept. Wait, sorry, nope. Okay, dokie. So yeah, now what this is saying is that the change. So now if we have you can if we, as you can see here, if you take any point x, y, any point, let's say here or here or here, wherever on that line, then they have that point x, y has to satisfy that point, the difference in the y value over the distance of the is equal to the slope times distance of the x value. So what that means is, like, if you see here, we have y minus y1. If you divide both sides by x minus x1, we get this. Alright, so this is saying find all points x, y that satisfy y minus some y value over x minus the corresponding x value is equal to the slope. This is the definition of slope, right? This is delta y and this is delta x. Delta means change. So yeah, that's basically the definitions of slope using one point and a slope. You can find that. Alright. Next up is intercept form. No, sorry, standard form. Ax plus by equals c. Alright, so now in this case, this helps us find the intercepts easier. What this says is that, oh, it just shifted. Alright, yeah, so let's say we had a equals, sorry, yeah, let's say we had x equals 0. If x equals 0, then we'll find the y coordinate. So the y-intercept is c over b. And then you can use the same method to find the x-intercept. It's equal to a over b. Or sorry, c over a. You don't have to memorize these. You can really just work it out. Use just solving for x or y, letting the other one equal to 0. Alright, cool. Now, how do you find the slope of this? Well, what you do is if you can solve for y in this, so y is equal to negative a over b x plus c over b. Alright, so now negative a over b would be, negative a over b would be the slope, I think. Alright, and then you can divide by c on both sides to get a over c x plus b over c y. Oh yeah, that's right. Cool. Now a over c x plus b over c y equals 1. In this case, you can set x or y equal to 0, and then this one, yeah, and then this, it's going to be even easier to find the x-intercept and y-intercept, right? Because yeah, this is just much easier. In fact, you can also do 1 over both sides. You can take your reciprocal of both sides to get 1 over yeah, you can do a lot of things, but this you can do that and you kind of get an intercept form. So yeah, that's cool. So that's the forms of lines. Now let's talk about some systems of equations. If this, what the heck? I don't know why it's doing this. now let's talk about linear systems of equations. So first let's talk about solving these basic line stuff, right? So let's say we had let's say we had ax plus b equals c, solve for x. You can do the opposite of every operation, one by one, like reverse PEMDAS, and then you get x equals c. You first subtract b, and then you divide by a, so you have c minus b over a. Cool. That's how you solve these. You can, that's how you solve them. So if you had, I know I'm not going to do any examples, but we'll try one. Like this, you subtract 2 on both sides, you get 3, divide by 3 on both sides, you get 1, and that's it. If you have something like 3x plus 6 equals 12, you can either first subtract 6, then divide by 3, or you can first divide by 3 since they're both divisible by 3, and then you can do x plus 2 equals 4, subtract 2, you get x equals 2, or you can do x 12 minus 6 is 6, 6 over 3 is 2, so either way you get x equals 2. Cool. So now linear systems of equations, that's where we have more than one equation and we have more than one variable. So let's say we have something like okay, cool. Let's say we had, oh my god. I'm trying to do this fast, but it won't let me. Okay, cool. So yeah, now let's talk about systems of equations. So now, if you have n amount of some amount of variables, you need that exact amount of equations. Most of the time. Sometimes you don't, but because you can generate equations. So let's say we add 3x plus 2 equals, 3x plus 2y equals we'll say 14, and then we add 4x minus 5y equals negative 12. Alright, so now how do you solve this? How do you solve for x and y? There's three ways actually. You'll learn a fourth way later on also, but for now there's just three. So number one is substitution. What you can do is you can solve for one of the variables in term of the other and then substitute it in for the second equation. So let's say in this case, if we solve for y, what we get is y equals negative 3 over 2x plus 7. In this case, if we solve for y, in this case, because y equals this, you can substitute that in for the y to get this expression. We get 4x minus 5 times negative 3 halves x plus 7 equals negative 12. Now we just have an equation in terms of x, so now we can solve for x using our typical methods. And with fractions it gets a bit harder, but that's fine. We can still use our methods. So if we simplify this a bit, we get 23 over 2x, I think, minus 35 equals negative 12, or x equals it works out pretty well. X equals 2. Cool. We plug that in. Yeah, so x equals 2. Cool. Yeah, now we found x, but we're not done. We need to find y as well. So we can look at one of these two equations, right, where we started, and we can plug in x equals 2 So we have, let's say we had 6 plus 2y equals 14. Subtract 6 divided by 2, or divided by 2, then subtract 3, and we get that y equals 4. Cool. So, or we could substitute it into the second one. We get 8 minus 5y equals negative 12. Subtract, or yeah. So y equals 4 again. So cool. That's one method. You can also use elimination. Elimination is where you kind of do operations with the equations to getting a better equation that you can use more tricks on. This is more helpful in competition sometimes. It won't be just linear systems of equations. It might be some squares and stuff, and you can do some cool things. You can multiply two equations together, but we're just going to be talking about adding and subtracting. So if you have the same equation, right, we already know the answers, but we can solve it another way. Sometimes this way is easier, sometimes the other way is easier, sometimes the third way is easier. It just really depends on the situation. Alright, so now what's elimination? So, okay, so the goal is to get one of these terms, x and y. Alright, you want to get God, this is really slow. Okay, so you want to get these two or these two. Oops, what am I doing? Or these two to be the same. Notice there's also a plus sign here. Alright, so you don't want their, it doesn't matter about their positive or negative. So really what we can do is we can wait. Cool. So we really just want these to be the same. Pretend the plus sign's out of the circle. And we want these to be the same. Alright. It doesn't matter the sign. So yeah. And we can't really do that from magic. So what we can do is we can multiply one equation. We can find the LCM basically. And then we can manipulate the equations to get that. So so let's focus on x. We want the coefficient of x to be the same, but they're not the same. So we can find the LCM of 3 and 4, which is 12, and then multiply each equation by the LCM divided by the already coefficient. So now, this is already 3. To get to 12, we need to multiply by 4. So we multiply this first equation by 4 on both sides, which doesn't change anything. And we get 12x plus 8y equals 56. And then we multiply the second equation by 3 to get 12 as a coefficient of x, to get 12x minus 15y equals negative 36. So we find which one would be easier. So now yeah, what we do with elimination is, because these are the same now, if we subtract one equation from the other, we would still get a valid equation, but we would cancel one of the x's. So whichever one's easier to do, which I would say is subtract the second one from the top one, we'd get these cancel. That was our goal, right? That's what elimination does. And then we get that we subtract 8. So this negative 15y becomes a 15y positive. Add that to 8y, we get 23y equals, you add, then negative 36 becomes 36 positive plus 56. That gets us 80 plus 12, which is 92. Alright, we divide by 23 to get y equals 4. Again, cool. So now we get that same y, we plug it in to get x, right? But what we can also do is we can also eliminate y. We were aiming for x. So we do the same method and we get the LCM is 10, multiplied by 5 on the first equation, we get 15x plus 10y equals 70. Second equation, we multiply by 2, we get 8x minus 10y equals negative 24. Now notice that these sides are not the same, so we're not going to subtract them, otherwise we're going to get double. So what we're going to do is we're going to add them, because they're opposite signs, and we want them to eliminate. So what we do is we get this is 23x, these go away, and that's equal to 70 plus negative 24, 70 minus 24, that's going to be 56. So x equals 56 over 23, which is equal to, or 56 over 23, which is equal to, wait, what did I do wrong? Sorry, no, this is 46. You get 2. Cool. And then we can substitute it in. Alright. You could do both, but I'd say you do only one of these methods and then substitute it in to find the other. So now, that's cool. So it's good to check it in to make sure it works also, right? And then, so notice that when we eliminate x, we get y. When we eliminate y, we get x. So yeah, when you have 3 variables and 3 equations, they're gonna have to take pairs, and then when you eliminate one variable from each pair, you get 3 equations with only 2 variables. And then, or you don't even have to do all pairs. You can just choose 2 pairs that have a common variable, and then you can just really simplify from 20 equations to 19 to 18 down to 2, and then that's also happening to the variables. So yeah, that's how you do these systems of equations. We'll talk about more advanced ones later on. So yeah. Now, factoring and expanding expressions. So basically, distributive property says that a times b plus c equals ab plus ac. If you were to expand this into algebra 1 and algebra 2, we're really saying that f of x times g of x plus h of x equals fg, sorry, what am I doing? Yeah, sorry, f of x times g of x plus f of x times h of x. I'm going to rewrite that, sorry. That was not that good handwriting. Let's read that again. So we have that that's equal to f of x times g of x plus f of x times h of x. So you're still distributing it. In short term, we can write that f times g plus h equals fg plus fh. Alright, and that's the same as before. Notice that in this case we don't have normal numbers or variables, but rather we have a whole function at the whole time. So we have f of x, which is a function, g of x, which is a function, and h of x, which is also a function. So now this will help us a lot in factoring and simplifying. So we can not only equal, we can also do it both ways. Cool. Now, let's say this is all you need to know. So you can check out the factoring and simplifying video specifically to learn more. So if we had normal stuff like right, then we can just do the distributive property, but that expands more. So let's say we had a plus b times c plus d. You can use the distributive property, or you can use this thing called FOIL. So the FOIL is derived from this distributive property. So the distributive property would say that this is equal to a plus b times c plus a plus b times d, right? Now we can do the distributed property again to get AC plus BC plus AD plus BD. Alright, and you can do this for more terms and more and more and more. And not only variables and numbers, we can do it with functions like before. But they're all derived from this one thing. And yeah. FOIL just says first, outside, inside, last. So you do the first, which is A and C. Then you do the outside, which is A and D. Then you do the inside, which is B and C. Oops, what am I doing? Sorry. Then you do the last, which is B and D. Cool. I'm not really changing the color much. I need to do that more often now. So yeah, that's that. There's also a thing called Simon's favorite factoring trick from AOPS. It's really just FOIL backwards. Alright. So there. Cool. You can also use the commutative property of addition and multiplication, and you can also use a property that if there's an equality of two statements, then you can do it both ways. So you can use those three things and distributed property and the function way of the distributed property to kind of derive all these. So yeah. Let me actually talk about expanding expressions a bit. So let's say we had x squared plus 3x plus 2 times x squared plus, or actually 2x squared plus 1 times 4x minus 7. Now there's more, but we can use the same thing. We can say that we can use this at once, and then we can multiply this by that, and then that. Alright? Then you can just keep moving on like that. Alright? You can use associative property for this. And also, when you're expanding expressions, what you can do is you can multiply every term in this by every term in this by every term in this. So you take 1 from this one, then 1 times that 1 times 1 times, and then multiply that. So you just pick 1 from every term and then you multiply them. So let's say when you always want to do it organized. So we'll first choose x squared, 2x squared, and 4x. You multiply them. Alright, so let me make this a little more neat. So we have that and that. Alright. You can also choose x squared, then you can choose 1. Or sorry. Whoops. Okay, so we can choose x squared, we can choose 2x squared, and we can choose negative 7. Then we can choose x squared, 1, and 4x. Then we can always choose every combination. And a good way to check at the end, before simplifying it, is that there should be, before simplifying, there should be 1, 2, 3 times 1, 2 times 1, 2. You add, you count how many terms are in each big term that you're multiplying, and then you multiply those to get 3 times 2 times 2, which is 12. So there should be 12 terms before you simplify. After simplifying, there'll be less. Cool. I'm talking too fast. That sucks. Watch the videos that explain it much more in detail. Alright. So, oh, I see what happened now. Okay, that's fine. Okay, cool. Okay, alright, so now we're going to talk about special factorizations. I'm not going to talk about it in depth in this video. You can check out the other video to learn more on it. I'll just talk about what you really need to know. That's only a few things. So a plus b squared equals a squared plus 2ab plus b squared. A minus b squared equals a squared minus 2ab plus b squared. A plus b cubed and a minus b cubed. And then a squared minus b squared. Alright, so now, and then there's two more after that. So now this is equal to a cubed plus 3a squared b plus 3ab squared. If you know combinatorics, you can use the binomial theorem to find the general form of a plus b or a minus b to the nth. So yeah, that plus b cubed. This is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. With minus, you're really just alternating because because it's negative b, and when the power of negative b is positive, or when the power of negative b is even, then it'll become a positive coefficient. When it's odd, it'll become a negative coefficient. So here it's negative b to the first. Here it's negative again because it's b cubed. Here it's positive because it's b squared, or negative b squared rather. Here it's positive because it's negative b to the 0th. So yeah. Now we're gonna talk about a bit more that are not like this. They're a bit different. So we'll talk about them down here actually. So a squared minus b squared, that's equal to a plus b times a minus b, combination of both. Cool. You can also use a cubed plus b cubed and a cubed minus b cubed. This is equal to, this is equal to, this is equal to, you can really just derive it from sequences and series, right? Hopefully you guys might know that. Not a lot of you would, because it's Algebra 1, but if you do, you can use that. This is equal to a plus b times a squared minus ab plus b squared. And this is equal to a minus b times a squared plus ab plus b squared, I think. So yeah, if you see the relation with sequences and series, that's cool. There's more, but these are the main ones you need to know. So yeah. I think on time we're doing okay, but that's my opinion. And if this loads, we do even better. Okay, we're doing this again. Okay. That sucks. Okay. Let's do that. I actually spent a lot of time beforehand trying to learn how to deal with this. And if it was faster, I would be able to deal with it faster. Okay. Okie dokie. So, now, talking about so we're done with that. Now we're going to talk about factoring quadratics. First of all, hope you guys know what a quadratic is. If you don't, that is fine. We're going to talk about it right now. It's going slower. Oh, okay, yep, here we go. Okay, factoring quadratic. So a quadratic is in the form ax squared plus bx plus c. Remember linear equations? Yeah, they only have a power of x up to 1. We have a power of x up to 2. These, unlike linear equations, have up to 2 solutions. They can't have 3, can't have 4. Linear equations have up to 1. Sometimes they have infinity technically, but that doesn't really count. So yeah. How do you do this? Well, what we do is to factor it, First we're going to talk about if a equals 1. Then we're going to have x squared plus bx plus c. Alright, so now what we do is we find two numbers, p and q, such that p plus q equals p plus q equals c and pq equals b. So find two numbers that satisfy this equation. This is a system of equations, but they're not linear, so you don't know how to solve them yet. And if you do substitution, you're going to end up with another quadratic, and that's not going to be helpful at all. So you really just have to guess and check. Yeah. So once you find them, what you're going to get is, when you factor this, you're going to end up with x minus p times x minus q. Cool, right? I'll do an example in a bit. So let's double check. If you multiply this out, you get x squared minus p plus q b x. So yeah, we're gonna get, doing this right. Oh, sorry, no, I messed this up. I need to switch these. There. If you multiply these out, you get. Sorry, no. I think you have x plus q times x plus p times x plus q. You multiply this, you get x squared plus p plus qb plus pq. Cool. Yeah, sorry about that. So basically, you're finding two numbers p and q that add to b and multiply to q. Okay. Now, when you factor it, you'll get x plus p times x plus q. All right. And now, if you multiply that out, you get this. You get px plus. Sorry, God. You get px plus qx, but you can factor out an x to get p plus q times x by reverse distributive property. So now this, because p plus q equals b and pq equals c, we have x squared plus bx plus c, where we began. Cool. So now, you just have to do that. So let's say we had x squared plus 5x plus 6. How do you do this? Well, let's say so we have p plus q equals 5 and pq equals 6. Now p and q, so now obviously p equals 2 and q equals 3. But we can also have p equals 3 and q equals 2. But it doesn't really matter, because if we have p equals 2 and q equals 3, we have x plus 2 times x plus 3. And if you have p equals 3 and q equals 2, we'll have x plus 3 times x plus 2. So it doesn't matter. It's really, oh yeah, I feel good writing that. So now, we're going to do another one, but a bit harder. And then after that, we're going to move on to when a is not equal to 1. So let's say we had x squared minus 5x minus 6. Actually, x squared. Wait. Let's say, God. Plus x minus 6. Alright. So now, how do you solve this? Well, what you can do now Okay, there we go. So now, p plus q equals 1 this time. And pq equals negative 6. So now, notice that we have a negative, and p plus q equals 1. Notice that p and q do not have to be positive. They can be anything in the world, really. So, what we can do is we can, well, they can't, technically they can't be non-transcendental numbers, but like e or pi, they can in a way, but okay, anyways, yeah. So you do this, you can do some guessing and checking. So you can also include the negative number. So -2 and -3. Or sorry, yeah, and so yeah. So what we get is that p equals -2 and q equals 3, or vice versa. And that gets us to x minus 2 times x plus 3. Check it out, you get it. Cool. That wasn't that hard, hopefully. Soon we're gonna get to the most famous part of Algebra 1, which everyone dreads. But that will come soon, if this loads. This video is getting pretty long. Alright, now let's say we had ax squared plus bx plus c, where a is not equal to 1. Well, technically a can be anything, so there's no limits. This time what we do is we find two numbers p and q such that p plus q still equals b, but pq equals a times c. But this time, and after we find p and q, we're not gonna have that normal x plus p times x plus q. If we did this, we would have x squared plus bx plus ac, and that a is going in the wrong place. So what we need to do, if you notice carefully, is that we need to have one of the factors, the coefficient of at least one of the factors have to have a bigger coefficient of 1 for x. So we can't do this. What we do is we break up b into parts. So we have ax squared plus px plus qx plus c. Alright, because p plus q equals b still, so we can just break it up. And notice that p and a have a common factor, right, because this equation, and q and c also have a common factor because this equation as well. So we can factor them separately. Pretend there's a plus sign in the middle of those brackets. And then we can factor those, and then there'll be a common factor between those two, and then we can factor that. That was a little complicated, so let's test it out a bit. So we had 2x squared plus 5x plus 6. You know what? Let me write that outside. Oh my god. Alright. So we have 2x squared plus 5x plus 6. Or sorry, plus 3. So now p plus q equals 5, pq equals 6. Alright. Now notice that if we did x minus 2 and x minus 3, we would not get what we want. So what we do is we break up b to get 2x squared plus, we break it up, we can either put the 2x here and the 3x and x, or we can do the switching. We can switch these two. But we're not going to switch them because in this case it'll be easier to do our factoring. Alright? So if now we can factor these two separately to get 2x times x plus 1 plus 3 times x plus 1. And surprise, surprise, this will always work out that both of these factorizations will have a common factor again. And in this case, our common factor is x plus 1. So we can factor out x plus 1. When I say factor out, I know I didn't talk about it in this video, but that should be a pre-algebra topic. And if it's not, then you can check out the algebra playlist. So yeah, this is the factorization. It's common notation to do it's common math convention to do the 2x plus 3 first, since it has a higher coefficient of x, then do x plus 1. So that's how we factor that. Cool. With negatives, coefficients and stuff, it's a similar thing, alright? So yeah, that's how I factor quadratics. Now that's gonna lag probably when we go up here. Hopefully that was too hard, right? Okay. Now, let's talk about solving, graphing, and optimizing quadratics. Speaking of, I know I'm gonna sound really stupid. I forgot one thing with the systems of equations. You can just graph the equations and then find the intersection point. So if we had two equations, ax plus b equals c, or a1 plus, okay, there, and then a2x plus b2, oh sorry, forgot the y's, equals c2. Alright, now if we graph these, let's say we got this line and that line, alright, they intersect at this point. Otherwise, they'll keep going away from each other. So at this point, that's the solution. Alright, sorry about that. I just wanted to get that out of the way. Now, solving, graphing, and optimizing quadratics. When we solve a quadratic, there are many ways to do it. Oh my god. I swear. So again, we have ax squared plus bx plus c, alright? Now, what do you mean by solving? It's not equal to anything. What we typically do is we set it equal to 0. If it's actually, in reality, if it's equal to n, we can subtract n on both sides to get 0 on this side, and then we get c minus n on that side. Notice that c minus n is also a constant. So c minus n will really just get us another constant, and we're gonna have a similar situation. We'll set c minus n equal to d, and we'll have ax squared plus bx plus d equals 0. And we just need to solve that the same way. How we're gonna learn how to solve this. So cool, let's do this. One way to solve it is by factoring. So when we factor, what we can do is let's say when we factor, we get m1 times x plus n1 times m2 times x plus n2. Alrighty. Now, I want you to try to find out, if this is equal to 0, how do you solve that? Water tastes yummy, what can I say? Alright. So if this equals 0, we can't have them multiply to 0 unless one of them equals 0. Since multiplication by 0 means the whole product equals 0. So now this equals 0, or this equals 0. If we solve both equations, they're really just linear equations now. We can solve them. Speaking of a quadratic, it's linear factor times a linear factor. Yeah, so now we solve this, we get x equals negative n1 over m1, and x equals negative n2 over m2. So yeah, and those are the only two equations, since there's no other way to multiply to 0. So yeah, that's how you solve it, by factoring. Alright, so now let's say we had let's say we didn't want to factor it. Let's say it would have been ugly. We would do something called completing the square. So we have ax squared plus bx plus c. Alright, now completing the square is a cool tactic. It's where you make this into a square. So what we do is okay, so what do I mean by square? So right now, if we factor this, we get m1x plus n1 times m2x plus n2. And that's ugly. What we want is m3x x plus n3 squared plus k. Or actually, we'll not use k yet. We'll say plus say r3. Alright. So now it's really we're really having a square plus some extra term, a correction factor, if you will. This equals 0, this equals 0, cool. Now how do we get this? Well, notice that we want R3, we want the remaining thing to be a constant or the lowest possible like degree of x, right? So now, or have the lowest possible degree of x. So now so now we can find the square by defining a and b, and then whatever the extra is, we can use c and the extra number to find the R3. So here's what I mean. So notice that actually we want that a times that plus, okay, so yeah, sorry. If we divide by a on both sides, we get x squared plus b over a x plus c over a equals 0 still, because 0 over a is still 0. So yeah. Now, because you know what, we'll use f of x just to keep track. So this is f of x over a equals this, and then this is f of x. So yeah, now we have that. And if we divide, sorry, not divide, if we notice that we want the factor to be, sorry, there won't be any m3 because we're already dealing with a. So yeah, now if we have x plus n, actually we already defined n, let's say x plus s squared, alright, then we have some extra correction factors. So now what we want to solve for s, and we want to solve for the correction factor. We're going to change that to s, right? Equals 0. Alright. So now, if what we can do is we can expand it out to get x squared plus 2xx xs plus s squared plus r3 equals x squared plus b over ax plus c over a. Alright, we subtract these. We notice that notice that 2xs equals b over ax. So 2s equals b over a, and s squared plus r3 equals c over a. So now s equals b over 2a, but in this case s would be equal to something else. So we'll use this. Alright, so what we have is x plus b over 2a squared and now the extra is going to be b squared plus 4a squared. We can't just add that out of nowhere. We need to subtract it too. So we're going to subtract b squared over 4a squared, and then we're going to have our normal c now. So now r3 equals this. Alright, we can check that here. Alright, cool. So now this looks a bit more complicated, but what it does is it gets us a square, and that's going to help us in optimization, which I'll tell you about in a bit, and this. So now we have f of x over a equals this. So if we multiply by a, now we have f of x equals a times x plus b over 2a squared minus b squared over 4a squared plus c. Alright, so now, I think that's cool. We have a good idea, right? For short, what we can do is we can say this equals h and this equals k. So yeah. Now, that's pretty cool. Notice that the maximum of this graph or the minimum of this graph will happen when this factor equals 0. In other words, x equals negative b over 2a, and y equals f of negative b over 2a. What the heck? Alright. So that's cool. Yeah, sorry. Yeah, that's how you do that. And then solving it, you just have to kind of manipulate it, right? Let's actually do an example. Speaking of, we're gonna use our friend, right? Let's complete the square for x squared plus 5x plus 6 equals 0. So you can solve for this, right? And do it by completing the square. So if you complete the square, you get x plus, actually let's do our good old friend like that. There we go. So if we factor out it, we're gonna end up with 2 times x plus b over 2a, which is 5 over 4. That's squared. Now we can use our formula, but we can also just use our logic. We're gonna have I think I got this correction factor wrong. I'll check that in a second. But yeah, if you do this, you get 25 over 16 as an extra. So we need to do 3 minus that, so that 25 over 16 plus this correction factor equals 3. And that's going to be 48 minus 25, which is 24 over 16. That's equal to 3 over 2. So we have plus 3 over 2. Right? I think so. Hopefully that works. Yeah. Yeah, I think that's right. Okay. Wait. No. Sorry, no. When you do this, you are multiplying by 2 also. So you're going to get 25 over 8. And then 3 minus, so that's 24. So that's negative 1 over 8. You're doing ab squared. Okay, yeah, there. So now that becomes a. Alright, cool. So now, so instead of a squared there, it's going to become an a. Alright. Same thing here. Alrighty, so now, we have negative 1/8 equals that. So that's our correction factor. Alright. That equals 0. We can add 1/8 and then divide by 2 to get x plus 5/4 equals 1/8 over 2, which is 1/16. Oh yeah, this squared. We can do the square root to get x plus 5/4 equals 1/4. But notice when you take the square root, you're forgetting the negative solution. Because notice that 4 squared equals 16, but negative 4 squared also equals 16. And that's the same thing for a lot of numbers, alright? Because a negative squared is a positive. It's the same as a positive number squared. So, really, what we're getting is positive or negative. That's the sign we use for positive or negative. And then we can do x equals 5/4 plus or minus 1/4, which is equal to, if we do plus, we get 6/8 or 3/4, or sorry, 6/4 or 3/2, and 1 So those are our solutions. We plug them in to check and get 2. Wait. Oh my god. Sorry. No. We get 1/4 and then 5/4. So 1/4 minus 5/4 is -1. Okay, that would get us to 2 minus 5 plus 3. Alright, that works. Cool. So that's how you use completing the square. Now we're going to talk a bit more in depth of max and min. And then soon we're going to get to the quadratic formula, which is the formula to solve any quadratic. Because these methods take a while and might as well have a formula. The formula is hard to memorize at first, but after a while in high school, it typically just becomes muscle memory at a point. It's hard to find. Okay, cool. So we solve. So solving we did. Now graphing and optimizing. We're gonna finish solving in a bit. So graphing or optimizing is where we find the maximum or minimum. So let's talk about graphing before so we can get a visualization. When you graph it, what you get is you get this little curve. Alright? Alright. Here are some examples of parabola stuff, is what we call it. So, notice that they go off to infinity on both ends, alright? And they both go in the same direction. Either both go up or both go down, alright? Now, notice that they both have a tip. That they all have a tip. And then notice that they all intersect the x-axis at a maximum of 2 points. Here it intersects at 1. Here it doesn't intersect at all. They all have a y-intercept, but that would be C. And yeah, I also talked about problem solving with them a bit, I think, in another video. So check that out if it's there. Notice that they all only go in 2 directions. Either they both go up or they both go down. Right? I already said that, but like you can see that the tip is either there is a max or there's a min. There's not both, right? Now solving for that max or min, max and min are short for maximum and minimum, respectively. So yeah. So these points that intersect the x-axis, they are the value that they're the answers. They're the zeros, the roots. In this case, this has no real roots, and we're gonna see that in a second. Notice I said real roots. Here it has only 1 because its tip is on the x-axis. What that means is that it's a square. It's x minus n, and then you square it. So notice that this only has one solution, x equals n, and that's this point, right? So cool. Because if we set that equal to 0, we take the positive or negative square root. The positive square root of 0 and the negative square root of 0 are both 0. So that's why there's only, and then x minus n equals 0, so x equals n. Cool. And now graphing, really just have to find those special points, right? You find these special points, and then you find y-intercept, right? Y-intercept, x-intercept, maximum or minimum. Then you find direction, which I'll talk about in just 1 second, and then you just find some random points that are easy to plug in. Now the direction, how do you find that? Well, it'll point upwards, and will have a minimum if a is greater than 0. Alright? Sorry, what am I doing? So it loads. Alright. Loads. Be very happy. Okay. We'll just have to go for it. Alright, sorry. Yeah. So now, if a is greater than 0, it points upwards and has a minimum. If a is less than 0, which means a is negative, then it'll have a maximum and it'll point downwards. Alright? And that kind of makes sense in a way. Alright? So now we know how to graph it. Now optimization, we find these maximum minimums, right? What we do is the x value of these maximum or minimums is equal to negative b over 2a, right? We found that down below. And then we find y is equal to f of negative b over 2a. So yeah, that's it on optimization. Now let's get back to the solving. How do we find the quadratic formula? How do we find a general solution for all quadratics? Oh my god, this is so slow. This wouldn't be an hour long if it wasn't this slow. Alright, so the quadratic formula. Alright, we're gonna derive it really fast. Alright, super speed. And we're gonna be using completing the square. So this is equal to 0. We divide by a, we get x squared plus b over ax plus c over a equals 0. The quadratic formula, by the way, is solving for what x equals. We subtract c over a to get x squared plus b over ax to get negative c over a. We can add b squared over 4a squared, I think. Wait, hold on. Yeah, we can add that. We can add this to both sides. Then we factor this side as a perfect square to get x plus b over 2a squared still equals this. Alright, not too nice so far. We take this positive or negative square root to get x plus b over 2a equals a positive or negative square root of negative c over a plus b squared over 4a squared. Then we subtract b over 2a. If it loads, I'd be very happy because we're about to solve it. We subtract b over 2a to get x equals negative b over 2a, or sorry, b over 2a to get this plus or minus the square root of b squared over 4a squared minus c over a. Alright. We can simplify this a bit to get x equals negative b over 2a plus or minus the square root of b squared over 4a squared minus 4ac over 4a squared, which is equal to negative b over 2a plus or minus the square root of b squared minus 4ac over 4a squared. Notice that if we split this up, the square root of 4a squared equals 2a. Oh, what am I doing? Okay, cool. Alright, so now we get square root of b squared minus 4ac over 2a, and that is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Whew, that's a handful. You can sing a song to remember it, you can just remember it, you can just look at it. I like to look at it in parts, right? You have negative b, then you have plus or minus square root, then you have b squared minus 4ac, then you have 2a. Fun fact, this is probably the most complicated thing in the whole thing. That's a surprise, right? Well, it's also the most important. Because it makes you struggle the most. And because it defines the variable, or defines the answers. So, let's say, so now, that's what we call the discriminant. Sometimes we denote it with an upside down triangle. But we don't really at all times because it's more used for Laplace transform and stuff like that later on, or whatever smart people do. So yeah, if this discriminant is greater than 0, it's less than 0, and if it's equal to 0, we can use these three cases to define our solutions. Alright? Alrighty. Cool. So yeah, now if it's greater than 0, then the square root is also greater than 0. But then the positive or negative makes a positive or negative number. So this means that we have real roots. We use this weird R to denote that. If it's less than 0, then we have the square root of a negative number, which is not positive, which is not possible. Sorry, it's not positive. It's not positive either. So what we're gonna get is we're gonna get a thing called a complex number, and we're gonna learn about that a little more later in Algebra 2. So don't worry about this. Really, we have no real solutions. Okay? And if it's equal to 0, then we have negative b plus or minus 0 over 2a. So we have negative b over 2a. In other words, we have a perfect square, or otherwise known as a double root. Alright? Or known as a root with multiplicity 2. You're going to need that later on in Algebra 2. What multiplicity 2 means is that on the graph of it, if it intersects it once, it looks normal, right? Just intersects it. So it has multiplicity 1. But if it intersects it like this, it has multiplicity 2. And we're going to find out more. If it had 3, it'll look a little like that. If it had 4, it does more. Yeah. So has multiplicity 2. So yeah, that's it on that. Let's see if there are more topics. This is a lot longer than I thought it would be, this video, but it's fine. Hopefully you guys learned a lot. Yeah. Oh my god. Okay. So yeah, we learned this. Now average rate of change. This is just gonna take a second. This is more of a calculus topic, but whatever. Yeah, let's say we had a graph, alright? Doesn't matter what the graph is. Alright? Now, if you want to find the average rate of change from 2 points, we pick one point, pick another point. Alright? Now in calculus, you're gonna find the instantaneous rate of change. Right? The average rate of change is where we just connect these 2 points and we find the slope of this line. Alright? Alright, we know how to find the slope of a line. calculus is more finding the slope of a curve, which we're not going to do now. That's kind of weird. So, finding the slope of this, how do we do that? Well, let's first define these points. Let's say this is a, that's x value, then the y-coordinate is f of a, right? If this function is equal to, is y equals f of x, right? That was kind of, yeah. If this is b, then we're going to have f of b. Come on, there we go. So now, if we have these, then the change in y is going to be b minus a, sorry, f of b minus f of a. And then the change in x is going to be b minus a. Alright? So, yeah, sorry. So that's equal to f of b minus f of a over b minus a. We can also do it the other way around to get f of a minus f of b over a minus b. Either way. So yeah, that's average rate of change for you. But you can do f of b minus f of a over a minus b, or vice versa, or like f of a minus f of b over b minus a. You have to do the corresponding ones. So yeah, that's it on Algebra 1. The main topics, if there are any other topics you could think of, they're probably in Algebra 2. So I'll see you next time. Bye-bye.